line. What is the midpoint of -5 and 17? Okay. What a real number line is, guys, is if you think back to, oh, hold on. I somehow took off my board. Okay. If you think back to elementary school, when you made number lines, and you said -5 and 17, you're just going to find your halfway point. That's what a midpoint is. Now, rather than counting out all the scale marks, because that would take a long time, we just go 17 to -5. But the reason why this one's kind of tricky is because if you go 17 minus -5, it's going to add 5, right? So there's a distance of 22 right in between. But see how it has 11 and a 12? It's because you divide 22 in half. So what you can do rather than draw it on a line, you can go like this if you wanted to. Okay, now you don't have to do this way, but this will kind of let me explain it the easiest. I'm running out of space, so here we go. 9, 10, 11, 12, 13, 14, 15, 16, 17. So if I cross off 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and I cross off 1, 2, 3, 1, 2, 3, and then I've got 4, 8, 5, 7, halfway is 6. Okay? Now, a faster way you could do that, you could say 17 minus a -5. Those are a distance of 22 numbers apart. And so a midpoint is halfway, right? Half of 22 is 11. Oh, I wrote 22 divided by 11. Excuse me. 22 divided by 2 is 11. So I'm going to take 17 and subtract 11, or -5 and add 11. And either way, I end up with 6. That's it. Now, question is, who would do it the way where you write out all the numbers? Yeah, I don't. Who would do it the way where you subtract it and divide? Right on. Now, here's the thing is, the ACT is not necessarily about changing the way you think, but speeding it up, right? So it's worth it to do the method that makes the most sense to you, because then you can accelerate the process, right? You don't learn a new technique and then try and change it up in the middle of it. We good with that? Okay, next one. Sorry, I just want to make sure I'm checking my answer right after we had some of the letters mixed up last time. Okay, number 2, on the real number line below, the coordinates labeled, an object moves left or moves according to the set of instructions. From the point P, the object moves right to Q, then left to R, then right to S, and finally left until it returns to its original position at P. What is the closest estimate of the total length in coordinate units of the movements this object makes? Okay, now this question, guys, we're going to do it and then we'll kind of talk about why it's hard at the end, okay? So what it says, from point P, the object moves right to Q. So I'm going to kind of draw this in shifts. First we go P to Q, okay? So Q is at 5. So -4 to 5, this is a distance of 4 plus a distance of 5. And I'm going to put over here a distance of 9. This is going to be our distance column. Now you don't have to use a column, it just kind of helps me stay organized. Okay. Then from Q, it goes over to R. So it's going to come from 5 back here, and R is at -1, right? So from 5 to -1, if negatives kind of mess with your brain, think of it as 0 to 5 and 0 to -1. A distance of 1 plus a distance of 5, that's a distance of 6. And then it says right to S. So from R, go over to S. So this is -1 to 8. -1 to 0 is 1. 0 to 8 is 9. When you add that 1 to it. Am I going too fast? Okay. All right. And then it says in final left until it returns to its original position. So it comes from S all the way back to P. So this is 8 plus 4. That's a 12. Okay. And it says, what is the total estimate, or closest estimate of the total length in coordinate units of the movements this object makes? So you add them all up. 9 plus 6 plus 9 plus 12. And that was a weird 3. Sorry. That is 36. So your answer is E. Okay. Now, question folks. Sometimes like that math is not too crazy. Now, why is this question hard? Think about what are they trying to do on this question? Why is it hard? The wording, right? They're trying to intimidate you because whole 3 lines you gotta read. Very not as straightforward. That makes sense. Not very straightforward. Okay. So just watch out for that. That's kind of typical ACT question. Okay. All right, number 3. And we'll kind of start mixing it up. We're just going to do a couple to kind of get into the swing of numbering quantities. Okay, if the inequality, the absolute value of A is greater than the absolute value of B is true, which of the following must be true? Thumbs up, we remember how absolute value works. Thumbs up, we used to know how absolute value works. Okay, no worries, let's kind of go through it. So absolute value, guys, what this means is that whatever you have inside, and I'm just putting a squiggly line, so it can be numbers, variables, whatever, and I'm going to use a number in this instance, whatever number you have inside the two lines always comes out positive, okay? And it's kind of weird because it's an operation, but it doesn't really look like an operation. It's like adding a number or subtracting a number. The operation is you just turn whatever's inside the bars into a positive number. So if this says that any value of A is greater than any value of B, because these are always positive, right? So that means that the positive value of A is greater than the positive value of B. So A could be like a 7 and B could be like a -2, okay? But then this would still turn out to be, like if A was 7 and B was -2, this would turn out to be a 7 and a +2. You okay with that part? So you have to say which one of the following must be true. Now these questions are a little tricky sometimes because you have to go through your options, right? So it says A and B are equal. Now that one, I probably wouldn't say so because it just says that this one's always bigger, right? So I'd probably say, well, we can't assume that they're equal then. So we cross off A. Now B, we say A does not equal B. Well, that could be true, right? But maybe we come back to that. We're like, well, let's look at our other options, see what we got. Now, A is less than B. Is it possible that A will be less than B? So rather than thinking about like, where is it going to work, we think about like, how can we break this argument down? Think of it as kind of like a debate class a little bit. So if the absolute value of A is always greater than the absolute value of B, question here, folks, could this happen? Could you have like a -2 is greater than a -1? Now, which number is necessarily bigger before you put in absolute values? The 1, right? So this one breaks down with that. That one's out, okay? Are you okay with why that one does not work? This is where it gets a little tricky. Now, A is greater than B. Is that necessarily true? Well, this one right here kind of breaks that down, right? So we could have, like, it could work another way, right? We could say that this is a -3, and this is like a -5, right? But then, see how this one, is that going to work out opposite value-wise? No, right? So, right here, hold on, I think I crossed off the wrong one, guys. I meant to cross off this one. We have that A cannot equal B, A is less than B, but that one might not work, right? And then on our last part right here, A is greater than 0. That's not entirely true, right? Because we can have an absolute value here. So the one that for sure we don't have an argument to back up with is B, okay? That's going to be the one, because they're not equal because of this inequality sign. That's the only thing we can rely on with that. So here's the thing, guys. When in doubt, like the variables are like, I don't know about the variables, plug in numbers. Like, see, like, how can I make the numbers match up with what my variables are doing? How do I feel about one like number 3? Are you okay with that? Kind of iffy. Okay. Any questions? No? You ready for a 1-minute one? Because this one's more of a word count. A little bit more, it's not so much logic based, like all variables. This is a little bit more like real life stuff. Okay? So number 4, I'm going to read through it, and then we'll start our minute. Mr. Dietz is a teacher whose salary is $20,570 for this school year, which has 185 days. In Mr. Dietz's school district, substitute teachers are paid $80 a day. If Mr. Dietz takes off a day without pay, and substitute teacher is paid to teach Mr. Dietz's classes, how much less does the school district pay in salary by paying a substitute teacher instead of paying Mr. Dietz for that day? Okay? Yeah, 1 minute starting now. Where's it go? Thumbs up when you finish. Sign. No worries, you still have a long time. You're okay.
What did you
March 26th. Tuesday of the last week of March.
15 days, 3 tomorrow.
Yeah.
So,
No.
I'm prepared.
Yeah, that's the other figure out for right now. Okay, 5 seconds, folks. Time's up. Okay, Who says A? Who says B? Who says C? Who says D? And who says E? Okay, the right answer, folks, I'm going to look off the back, is A. So let's talk about how we got it. Anyone want to tell us how they got there? Jackson and Milana and Nikki.
I took 22,770 and I divided by 187 days, or 185 days
Okay.
to get his pay per day. And then I took that same thing and I minus it by 80. So they lost $42, or they paid $42 less than what they were to just show up for that day.
Okay, right on. Milana, what'd you do?
Same thing.
Same thing, Katie?
Same thing.
Same thing. Okay. So $22,570 is how much money he makes for the school year, right? 185 days. So his salary is for a year, but the sub salary is for a day. So like you guys said, money divided by day, get this number, which I'm guessing was 122. Is that right? Right on. And then this is the pay per day, right? So this is Mr. Deeks' pay, money per day, and then this is the substitute's money per day. And so then because of that, he gets $42. There you go. Who's doing pretty good like that? That is a totally fair game ACT question, folks. Here you go. Okay, number 5. Let me look at it real quick. Unless you have any questions on number 4. No? Okay. Ooh, this one. Yeah, let's do a minute on this one, folks. Well, maybe we won't because it's kind of hard to see on the board. So let me do it like this. We're gonna try and make it a little bit smaller.
Well, what if you have the chart in the first?
Oh,
the chart on the
good
board,
call.
and then we can look at
I like
question.
This is good. Okay.
It'll make her.
Okay. All right. Here's the chart. Okay. Minute. Ready, set, go. Once you got it, you still have some time. Okay, I think time is up in 5 seconds. All right, folks, let's see. Who says A? Who says B? Who says C? Who says D? Who says E? Okay, let's find out. The answer is C, okay? So, now this question, folks, is another kind of wordy one, okay? So, here's the thing. This section column, not super important. The one you need is the period column. This is the hour that the class is given. So in first hour, you got 21 people. In second hour, you got 2 second hours, right? Here and here. So there's 46 people. You got those two up. In third hour, you got here and here. You'll do like the darker circles. It's a little easier to see. So 23 and 25 is 48. Okay. In fourth hour, do a different color. 29 plus 28 is 40 plus 17, 57. Thank you. And then in sixth hour, 19. Okay. So look at all the people in class, each period. Next row. Now, the question is, it says they own 2 question sets of 30 calculators each. So you have 2 sets, 30 calculators. How many calculators do we have total? 60, right? But what's the problem?
8 or
Subtract 8. 8 are broken. So that gives you 52. So the question, for which of the following class periods, if any, are there not enough calculators available for each student to use school and calculator without having to share? 4th hour only, which is C. Thumbs up if you can do the math on that one. Thumbs up, the words are rough. Yeah, a little bit. So it's a lot to sort through. So this is really the process of learning how to translate it quickly.
yeah, translating takes too long. I was asking what one needed to share. What you said,
So you're gonna this is a really good question. So if you didn't see this question, guys, how she said you have like a lot of time like reads the question and process it. Some of the questions you're not gonna need a full minute for. Like some questions you're gonna get 4 plus 2 equals 10 to solve it. Like subtract 2 divide by 4, you got your answer. So you're not always gonna need the whole minute for one question. So then it's like you get another 30, 40 seconds on another question. Does that answer your question?
How do I keep track of that?
Well, you don't have to time yourself. So here's what I do. I wouldn't actually like time yourself unless like you want to pace yourself. But what I would do is I would do all the questions that I knew how to do really fast first. And then I would do all the questions like, for example, in high school, I hated geometry. It was like worse than negative science. They're not negative science other than in my existence. So I hated geometry. I was not good at geometry. So I would skip all the geometry questions and I would come back to the geometry questions because like I think I can figure this out, but it's going to take me like 5 minutes.
Okay.
But if you skip all the really hard ones, you get the most done and you go back to the hard stuff. So that's what I'm doing. So don't stress about that. Like I think when we do the practice test on Wednesday when we start it, I think you're going to be surprised at how much stuff you already know. Okay? Sound good? Okay. Alright, folks. I think we're going to skip number 6. Not because number 6 isn't important, but because number 7, I think is maybe a little bit more helpful. Okay? So, number 6, is ordering like partial pieces. It's kind of like this one. It's like you can't have decimals, so you have to round up to your decimal number. Are you okay with skipping that one? Number 6. Can you do number 7? Because this is one we haven't run into one like this yet. So, right here it says we got Kareem who's got 4 sweaters, 6 shirts, and 3 pairs of slacks. How many distinct outfits, each consisting of a sweater, a shirt, and a pair of slacks, can Kareem select? Okay. Now, thumbs up if you've seen a question like this before, folks. Okay. All right. Do you want me to give you a 1 minute head start then?
Yes.
Go for it. Okay. Minute head start. Beginning now. Basic go. Okay. Okay, you got 10 seconds, folks. Alrighty, 3, 2, 1, time. Okay, who says A? Who says B? Who says C? Who says D? Who says E? Okay, D is correct, folks. How do we get D? What did we do? Times all of them, okay? So, this is the multiplication rule. You take 4 sweaters times 6 shirts times 3 pairs of slacks. That was in the wrong column. Times 3 pairs of slacks. 4 times 6 is 24. 24 times 3 is 72. A multiplication table you might be more familiar with is 4 times 3 is 12 and 12 times 6 is 72.
It's the ones that only can be divided by themselves.
Yeah. So we're going to do a little bit of talk on this one. Yeah, so prime numbers, guys, here's the thing. This, unless you just know it as a fact, I think the easiest way to do it is probably do this. I say, okay, 30, 31, 32, 33, 34, 35, 36, 37. Actually, I'm going to write it smaller. and farther over. Hold on. Now, what you could do, you could honestly, if you wanted to, skip all the even numbers to start off with, okay? Because prime numbers are numbers that can only be divided by themselves in 1. So even numbers automatically are off, okay? Because they can only be divided by 2. So here's what I'm gonna do. I'm not gonna write out the 40s. These are all gone, okay? Then the next one I say is, okay, I can divide by 5s, right? So 35 and 45 are out. And now you kind of go through individually. So you got 31 and 41, 33 and 30 and 43, 37 and 47, and 39 and 49. Now, before you go in and try and divide everything, I start with 31. I think like multiplication tables. I'm like, I don't think of anything, so I'm gonna skip it for right now. 33. What can you think of that divides 33? 3 and 11. So that one's off, right? 37. Can you think of anything right after that? Not me either. 39. A 3 and a 13. Okay. 41. I'm not thinking of anything. 43. I'm not thinking of anything on that either. 47. So then 49. Oh, yep. So then right here, potentially you've got 5 numbers. Now that is an option, right? 5 is one of the answers. But so is 4, 6, 7, and 8. They do that on purpose. So here's what I do, guys. The base prime numbers, the ones that are like really helpful to know, are 2, 3, 5, 7, okay? And if you get to looking for a prime number, so if you start with 2, we could get all 7, right? 3 and 7, here's the thing. 49 is 7 times 7, right? So if one of these numbers can be divided by a 7, then the other number has to be smaller than 7. Thumbs up, we're okay with that, because this is the 2s right here. A 7 times a 7, that's the biggest number of 49, right? Because it's between 30 and 50. So every time I go down a number, it has to be a number less than 7 and multiplied. So like 45, right, is like a 9 times a 5. So this one's bigger and that one's smaller. So if you can know these 4 prime numbers rather than like know which ones are prime between 30 and 50, because they could change it up, right? They could say between 20 and 40. So if you just know like the prime numbers between 1 through 10, those are kind of like your most helpful ones. So you say, okay, can 31 be divided by a 2? So you type it in your calculator, doesn't work. Can 31 be divided by a 3? Nope. 5? Nope. 7? Nope. So 31 is definitely prime. 37, can it be divided by 2? Nope. 3?
Nope.
Nope. 5?
Nope.
Nope. 7?
Nope.
Nope. So 37 is definitely prime. 41, 2? Nope. 3? 5? 7? No. 43. 2, 3, 5, 7, nothing. 47. 2, 3, 5, or 7? No. So I hope that's the right answer. Is 8B, guys? G. Yeah, that is B in corresponding variable language. I don't know how the letters got mixed up, but it's your second one, guys. Now, here's the thing, folks. This is a question that maybe I would try. This is kind of maybe one I would skip too, right? Because could you figure this out? Yes. Does it take a long time? Kind of, right? But here's the thing. How long did it take us to get down to 5? Maybe like a minute, right? It was not too bad because we took out the evens, we took out the 3s and 5s.
Write even the evens, just write all the odds.
Yeah, you just write all the odd numbers like Leon said. You start with that. Really what BCT is about strategy. It's not so much about like knowing the math, like you gotta know the math, but kind of honestly, you just write out all the odd numbers, right? And then if you got 5, like that's a pretty good guess, right? It's gotta be somewhere close to that.
Like some of the ACT questions are like, how many you can use the formula, but there's some ways they can use like common sense to do it. Like, like looking at the answers, saying, oh, this is too big, or this is too small.
Well, and this is the thing, guys, that one of these is always the right answer, right? So in multiple choice, like it's always to your advantage to guess. You never want to leave it blank. I always say that's the ultimate sin of test taking. Never leave a multiple choice question blank. Okay. Are you feeling okay about this one? Okay. All right. Do we want to do 9? That's like a 9 and 10 are like percent questions.
You know, we just crossed out all the even numbers on
Yes.
You just do that with the 5s as well.
Yeah, did it with the 5s as well. Because those are the ones that usually like are the easiest for us to think of. Because usually, I don't know about you guys, when I learned how to count in school, you know, like 1s and then 2s and then 5s. The 3s are like ones that don't come quite as fast as my brain. Now, some of you might be better at me than that, but like that's why I just cross out those. Is that okay?
Yes.
Good question. Yeah. Any others? No? Okay, I'm looking at 9 and 10. They're kind of like percent and fraction questions. I think we could skip those and come back. Is that okay? I think we'll want to do 13, guys. We're going to do a fraction question. Okay, like a all fraction question. Because 10 and 9 are kind of like that, but anyways, I think this is going to be more helpful for this. Okay, so 13 and 14, we're going to do these two. All right, of the 804 graduating seniors, that is a lot, guys. That is a lot of graduating seniors. It's awesome. At Stern High School, approximately 2/5 are going to college, and approximately 1/4 of those going to college are going to a state university. Which of the following is the closest estimate for how many of the graduating seniors are going to a state university? Okay, so I'm going to give you one answer on this one. Beginning now, ready, set, go. Okay. See how far you get in a minute. Okay, you have about 10 seconds, folks.
Oh, shoot.
No worries. It's okay. All right, folks, let's see. Who says F? Who says G? Who says H? Who says J? And who says K? Okay, the right answer, folks, after corresponding with the answer key, is F. 80. Okay, so anyone explain this how you got there? Go for it, Dee.
You get 104 times 2/5 to get that answer, and then times that by 1/4, and then you get a number that's a fraction. So you do math and turn it into.
Okay, go for it.
I just did multiply them. And then it was 402 divided by 5, so I just did 400.
Oh,
It just goes to 80.
yep. You got it. So, let's kind of go through it alphabetically, folks. This is a question, so here's the thing. The ACT says on every ACT test, every question can be done by a calculator, which is 100% true, but it doesn't mean that every question should be done by a calculator, okay? Because your calculator can speed things up for you. So say you're like, oh, fractions and I are not friends, okay? What you can do is you change these on to decimals, and that's okay. I always think of like Finding Nemo, he's like, fish are friends, not food, right? It's like, fractions you might feel like they're not your friends, that's okay. But you can change 2/5 into a decimal on your calculator just by going 2 divided by 5, and you get 0.4. Yes, and so then if you go 804 times 0.4, it should give you the exact same number, and then you take that number, and what's 1/4 is a decimal, folks? 0.25, and then that's going to give you another number, right? So this is your second number. That's going to be your answer. And so with that, you can totally do it with the fractions. You just multiply 804 times 2 and then divide it by 5, because when you multiply fractions, you multiply the two top numbers, the two bottom numbers. And so then this number turns into 1608 divided by 5, which comes over here. So really it's 1608 divided by 5, or that you multiply by, which gives you 608 divided by 20, which rounds to 80. Okay, I think it would come out to like 80.12 something, I don't know. 4. Okay, there you go. Somebody do that one. So here's that. Keep in mind, guys, the fractions are like an intimidation factor. Kind of psych you out. Okay. All right, number 14. We're gonna give you a minute head start on this one. Okay, you ready? Set. Go. Still be questions. There's a couple ways to get it. So you can do this. Or you can also just type it in as a fraction. So
I know what it sounds.
Oh, divided by 5.
okay. So you have 402 divided by 5. So instead of doing like that fraction, I'm going to shortcut like this. So if you do that, it will be just a fraction. You have to put a decimal in, so you have to go like 402 divided by 5. Just a division problem that you get that big, so it becomes math, and it'll change it to a fraction. Or substitute decimal. You can change it back to a fraction. Okay, folks, time's up. Sorry, I didn't realize that. Okay, least common denominator. Who got A? Who got B? Who got C? Who got D? Who got E? Okay, right on. Looks like B is the winner. Which is correct, folks. Anyone want to tell us how they got there? What do we do?
Yeah, it's kind of confusing.
No worries, you good. We'll have Kate go because you went last time. So okay, yeah, go for it, Kate. Take it away.
I just went to the highest number, 15, and then see if any of the, like, 15 times 2 times 3 were divisible by nothing, or 3 or 2. Which 45 is almost divisible by 1, but it is divisible by 2. So you go to the next highest one, which is.
Oh, not timesing. Sorry, you're saying dividing. Oh, no, you were saying timesing?
Yeah.
Okay, sorry, I thought you were wrong. Keep going, sorry. My bad.
It's 30, 45, 60, 75, 90. Oh, I didn't do that, but yeah, you can do that.
Wait, I'm confused.
I just want to 15, like 15, 30, 45.
Oh, right here. You meant this was a 4.
Yeah, and then
This was okay, sorry, I'm confused. So you need to
I guess that works too.
No, this is good. There's a lot of ways to do this problem. That's what I wanted to ask. So you said like this, and then when you got up to 15 times 9. No. I'm confused.
I know what he's doing because he's.
Yeah, go for it. Take it out.
Okay, so you do like the 30, 45, 60, 75, 90, and then you see, okay, you go on each of those and you say, okay, can 2 go into that, can 3 go into that, can 9 go into that. So like 9 can't go into 30, 2 can't go into 45, 9 can't go into 60, 2 can't go into 75, but everything can fit into 90.
Yes, okay. I'm sorry. I understand now what you're doing. I apologize. Okay, so you said 30 can't be divided by 9, but it can be divided by 2 and 3 and 15. 45 can't be divided by 2, but it can be divided by 3 and 9 and 15. 60 can't be divided by 9, but it can be divided by all the other 3. 75 can't be divided by 2, but 90 can be divided by everything.
Yes.
Good call. Do you get the point?
Yeah.
No worries, go for it, Ashley.
I just substituted 1 for all the letters, and then I added them all.
So 1, 2, like so?
Yeah.
So that, you did,
So not.
or,
It was 91 over 90.
okay.
That's just what I did.
Oh,
No, you're
that's
good.
smart. No, you don't do
Yeah.
multiplication in between. You do.
Yeah. So you're saying, because then you got a common denominator for all of them. You just typed in your calculator.
Yeah.
Call. Yep.
I was like,
No, that's great. No, that's great. That's great. This is where your calculator can help you out of time. Any other ways we did this? This is how I want to do this question. There's a lot of ways to do it.
The one you accidentally wrote, is that just like times 9 instead of 4 with the.
Yeah, except you don't, because, you don't always need a common denominator when you multiply fractions, so you want to do, actually, you want to add.
Yeah, alright.
I mean, I was just thinking, I was in my head.
You can look saying, okay, like start from the bottom.
Yeah, I just like automatically.
Okay. So Dylan said you can look at the answers and start from the bottom and see. So like 45, you can say, can 45 be divided by 2, 3? So it's kind of like this method.
Yeah, I did like a combination.
Yeah. So you have 45, you say it can't be divided by 2, but it can be divided by the other 3. 90 can be divided by all of them, so that's your smallest number, and so that would be your answer. Yep. Guys, this is great. This is great. Any other methods? No? Good. Okay, maybe we got time for like 2 more questions, so let me pick. I don't think you should exponent rules. Ooh. We're gonna do number 18, folks. We're gonna do 18, and then what are we gonna do a matrix one, 20 or 21? Matrices are a long time ago. Okay, do you want a minute head start on 18? Sure. Yeah? Alright, ready, set, go. Number 18.
You're probably right though, because I just like know that. It would just be the exponents.
Oh, hands up, guys, sorry. In 3 seconds. I need something warning. Alright, I see now, like, how do I solve this? So, okay, who says that? G. I always forget what we skip. H. J. K. Alright, so we got K majority, which is also what I got. How do we do it, guys?
That's so.
Go for it, C.
So I just figured out what a2 squared was, wrote it out on my paper, and I just plugged in the equation for every single one. And once so I did the middle one, 4 first, and I was like, okay, the ones less than 4 can't work. And then I just went up and figured out.
Okay, so you went to here. This is great. So you went to the answer, plugged in the answer right here with this 4, said these two were not equal, and so you knew everything less than that was out, and so then you tried J and K. Right on. Good strategy. Any other strategies, folks? Yeah, go for it, Nikki.
I did 8 to the power of 3 divided by 4, and then I got 128, and I thought 7 would be a good number for that.
Okay, and you just like took a gamble on 7.
I tried it, and
And it worked. Oh, that's great. Right on. Okay, go for it.
I did the same thing the first one we did,
Uh-huh.
but I went by 2, and then I just jumped 7 because it was way bigger.
It was great. So, okay, so you started with the smallest until you went to the biggest.
Yeah,
Right on, folks. This is good. See, isn't it cool how everyone's brain can do something different? And it's going to, either way, this is why I love math. Sorry, this is why it drives me crazy. But, good call. Now, I don't think I'm going to show you the way I would have solved it, guys, because I think I like your ways better. My way involved changing the base, but I don't think that. What it would mean is, I'll just show you a quick version. What you can do is, you can write 4 is 2 squared, and then 8 is 2 cubed.
Oh.
There's a 3 here. So then if you have all 2s, so if you have like 2, this is x plus 2, and then this is a 2, and this is a 9. So you just ignore the 2s. And that's x plus 2 equals 9.
Oh.
I don't know if I really like my way though. This is
I
how
mean,
thought
it makes sense. It's a smart person way to do it, but it makes sense.
I don't think I like it though. I think I like your ways better. But yeah. Thanks.
Your way.
If it was a cool choice, I
So this is the thing, guys. Like you can pick. So don't like, because I think your ways are good. Like don't try and change the way you think. Just try and speed it up, right? All right, we're gonna do one last question. We're gonna do a matrix question, folks. Who has seen one of these before? Do you remember these? The last time you saw them was probably 9th grade. Did we like matrices?
I think I did. I just don't remember. I remember
Alright.
a canoe tipping over.
So, matrix multiplication, yeah, it goes over the waterfall, yeah. So, what a matrix is, guys, is it's basically an equation with all the variables taken out, okay? So what you can do is use it when you have a lot of equations. So, let me draw an example. Say you have something that's like 4x, like systems of equations, 4x plus 2 equals 3y, and 3x minus 1 equals equals 7y. I have no idea if this is an actual system of equations. But then you're going to put all the x's here, all the numbers here, and then all the y values here. And so it would look like this. You would have 4, 2, 3, 3, negative 1, and 7, just like that. Hey, Mr. Dilly.
How are you?
Good. How are you?
Great.
We're doing ACT prep. You want to come do math?
Yeah, come join us.
That's my last question.
We have an NPC doing matrix.
Okay, give me like 5 minutes. I'll be done. Okay.
Oh, no, I'm not, did you need to talk about?
Oh, no, I thought you said you
I'm
were.
rolling the halls.
Okay. No, you're fine. No stress. So this is what a matrix looks like, guys. So all the x's, all the numbers, all the y's. Okay. And you're going to take all the variables off because it's easier to do any operation more quickly. Okay, so you can like speed up the process. So right here, so the number of students participating in fall sports at certain high schools is shown by the following matrix. So right here you have 40, 60, 80, 80. So the 40 and 10 is 60 in soccer, 80 in cross country, 80 in football. The athletic director estimates the ratio of the number of sports awards that will be earned to the number of students participating in the following matrix. So tennis, 0.3, soccer, 0.4, cross country, 0.2, football, 0.5. Given these matrices, what is the athletics director's estimate for the number of sports that we earn for these fall sports? Okay. Now, here's the thing, guys. Let me double check and make sure. Yeah. So what you're going to do right here is kind of actually going back to what you're talking about, the waterfall multiplying. So you're going to take this matrix, 0.3, 0.4, 0.2, 0.5, and you're going to multiply it by this matrix, 40, 60, 80, 80. And if you're like, how do I multiply a matrix? Well, so glad you asked. How it works is kind of just like what you talked about, which I actually wrote it backwards. Hold on, let me erase my pen here. Okay. So, when you multiply something, I'm going to move this over here. It actually should look like this. For it to go over the waterfall, how you guys said. The first value is going to multiply in this matrix with the first value in this matrix. So it's this pattern of going over to the right and down. Okay. So 40 times 0.3 is your first value. And then here's the tricky thing about matrix multiplication, guys. You add it. You add it until you get to the end of the row. So now you're going to go 60 times 0.4. Okay. And then you're going to add this. I'm running out of space to add, so I'm going to put it down here, sorry. 80 times 0.2. And you're going to add this to your last one, 80 times 0.5. And you really can type this whole thing into your calculator if you want. Okay, 40 times 0.3 plus 60 times 0.4 plus 80 times 0.2 plus 80 times 0.5. And what do you get when you type that whole thing in, guys? 92. And so then this is what we call your last matrix, your answer matrix. And that's your final answer. So it looks kind of scary, but how complicated is the math? Not too complicated, right? You just add and multiply. But they put it in this format because it's something that you have to know how to do, right? So you multiply row by column. So this is one row with 4 columns, and this is 4 rows with 1 column. And how you know you can multiply things, guys? Because sometimes they have questions that say, can you multiply this matrix with this matrix? The inside number and the inside number have to match these two for it to be multiplied. The outside numbers can be anything else, but the inside numbers have to match. And then your answer, here's the cool part, guys. Your answer has to be the outside number by the outside number. So it's going to be a 1 by 1 matrix, which means 1 row and 1 column. You just have to add the 1 number by itself. So it's matrix multiplication in like 5 minutes. You okay with that? Now, here's the thing, guys. How many matrix questions do you see on the ACT? Like 1 or 2, I think, unless they've totally revamped it since I looked at a practice test. But not a lot. So, should you spend hours and hours studying this? Not necessarily, okay? Now, could it come in handy if it was like the last question, you're like, oh, I know how to do this. Yeah, right? But is it going to be the majority of the test? Probably not, okay?
Can you explain 21?
Yeah, I can explain 21. Are you okay going over time? We're like 5 minutes over. I'm okay to keep going if you want. Okay, we can do 21. I'll be done. So this is what's called the determinant. Now, this is a concept that is not something that we really talk about until you get to like it's a like an honors math 3 concept, so we don't always get to it, but it actually gives you the formula in the question. So it says, by definition, the determinant A, B, C, D equals AD minus BC. So this means that A multiplies with D and B multiplies with C, and you subtract them, okay? What you might see teachers do sometimes is they'll have 4 values, and they do a loop like this. So I've seen a teacher do that before. So that symbol means you multiply the first 2 and the next 2. It's not really a symbol, but it's kind of like how they draw distributing binomials. They draw arrows. It's the same idea. So what you're going to do is 2x times 4y minus 3y times 5x. Okay? So this is really 8xy minus 15xy. I'm going to switch sides of the board. So this is negative 7xy, but then is negative 7xy one of your answers? No, right? But here it tells you x is negative 3 and y is 2. So this is really negative 7 times negative 3 times positive 2 is a 42. Is J the right answer?
That's what I thought.
Yeah. Yep, 21 J. That's your answer, folks. So here's the thing. Sometimes they give you like a very tricky problem, but if it's not something that like you're always gonna have seen before, they give you the formula. Like it's something I guess they're like, can you read the formula from what we've given you? Go for it, Ashley.
Where'd you get the negative 3 to?
Oh, sorry. This part right here.
Oh, okay.
Yeah, my bad. I should have shown that a little easier. So yeah, negative 7 times negative 3, positive 21. Positive 21 times 2 would be a positive 42.
Okay, I like when they give us
And
the
can
equation.
I have
Yeah.
that with,
Nice.
and I just like type that first equation back into the stuff.
Yep.
So I didn't even have to be like,
Actually, I don't know. I don't know.
Ask it.
I didn't feel like it, so I just wanted to use my calculator.
That's okay.
I know this one.
Thumbs up, guys. You understand the math on this one. Are you okay with this one?
Yeah.
Okay.